complicated by the serial number and the validity period in the certificate. Remember that the first parts are the chosen prefix, and we need to have those two prefixes from the two certificates. We need to know them before we can start generating the collision. And generating the collision takes a long time. So the validity period and the serial number, which are set by the CA, are set when the certificate is issued. So we would not know what they are in advance. And if we can predict them, then we would be able to execute this attack against a real certificate authority. In 2006, they were using their own certificate authority just for testing purposes, which had predictable serial numbers and validity periods. So the main issue, the main problem that we had to solve in 2008 in order to really do this attack was figuring out how to predict the serial number and the validity period from a real certificate authority. Of course, the first step, which was much easier, was looking at which certificate authorities are still using AMD5 in 2008. We did this by collecting a large amount of certificates from random websites on the internet. And based on those certificates, we identified 6 different certificate authorities that had issued certificates signed with AMD5 in 2008. We looked at most of those certificate authorities, and the one that we decided to investigate more closely was RapidSSL. First, because 97% of the MD5 certificates we found were issued by RapidSSL, so they seemed like a pretty big target. But also because RapidSSL turned out to have some pretty convenient properties of their system that were very useful to us to do this attack. The first property was that their system for issuing certificates was completely automated, which meant that you submit the certificate, you go through a validation process, they send you an email with a confirmation link, you go to that website, and then you have this I approve button. The certificate is always issued exactly 6 seconds after you click that I approve button, which means that the attacker controls the validity period of the certificate, the date at which it is issued, and its length. You choose the length of the validity by selecting if you want a 1-year certificate or a 2-year certificate, and then the date when it's issued, you just pick whatever date you want, and you have to click that button at the exact right time. And in my initial testing, I was actually doing this by hand. I had like a stopwatch, and then I would keep my finger on the mouse button, and right as the second hand hit, the 0, then I click the button, and I got my certificate issued. And even doing this manually over a pretty slow DSL connection gave us enough accuracy to be able to get certificates issued at the exact second we needed, with almost always. Now, the second problem was, how do we predict the serial numbers? Well, yeah. Based on the reaction from the audience, I'm assuming that I don't really need to explain much. But yes, for those of you who are listening on the radio, the serial numbers are actually sequential. So RapidSSL just keeps a counter, and for each certificate that they issue, they increment the counter by 1. In this case, you can see a bunch of certificates that we have bought and the serial numbers that we got for them. If you look at the timestamps on the left side, you'll also see that almost all of them are issued at exactly 2 seconds past the minute. And this is because we were targeting that exact second. So this helps us a little bit, but we need to be able to predict what the serial number is going to be, not in the next minute, but about 3 days ahead of time. Because we estimated that it was going to take us 3 days to generate the colliding certificates using the big cluster of PlayStation 3s. So how do we estimate what the serial number is going to be in 3 days? Well, we can actually get the current value of the serial number at any time. We just need to buy a certificate, and this allows us to query the current value of the serial number. It also increments the serial number. So we have a query and increment operation that we can perform on this remote counter. And because of the money they charge for the certificates, each query and increment operation costs $2.25. So you want to be right the first time if you can, otherwise you might have to spend some money. I looked at the I think 9,000 certificates from RapidSSL that we had collected. We did some advanced statistical analysis using Excel. And this is a graph that shows the increment of the serial number over a weekend. You can't really see the y-axis because it's cut off on the screen, but the two horizontal lines, the upper bound and the lower bound of the increment, are 800 and 1,000. This means that pretty reliably, RapidSSL issues between 800 and 1,000 certificates each weekend, from beginning of Friday to Sunday night. So if we get a certificate on Friday night, we'll get the serial number. Then we can predict that on Sunday night, the serial number is going to be S plus 1,000. And this is going to be an upper bound. We're going to start generating our collision. This is going to take a couple of days. Hopefully we'll have it done by Sunday. On Sunday, we need to get that certificate signed at the exact time that we targeted. This is time t. And we need to ensure that we get serial number S plus 1,000. So a couple of hours before time t, we start buying certificates. This allows us to both query the number and also increment it as necessary. So if we see that it's maybe 200 lower than it should be, then we can just buy 200 certificates. Of course, while we do this, we need to monitor what the number is, because the serial number is also incremented by requests sent by other customers of the CA. But since we chose Sunday night to do this attack, the load on the CA was fairly low. So it did not interfere with our targeting too much. So this was the attack. This was the basic algorithm for the attack. Everybody just loves these PlayStations. I mean, you know that they're not actually running games on those. They're not that fun. They just have terminals with stuff scrolling. Yeah, so this is a picture of the cluster that we used, and it would take between 1 and 2 days to generate a collision on it. We estimated that it's equivalent to about $20,000 of computing time using the Amazon EC2 system, which is a really significant cost, but definitely affordable for anybody who really cares about having a rogue certificate authority. There's one more improvement that we made upon the original 2006 attack. And this was a fairly important improvement for the impact of the attack, because in 2006 we could only generate certificates for a specific website. So if you wanted to man-in-the-middle example.com, you have to spend these 3 days generating the collision for example.com, get it signed at the right time, but then you can only man-in-the-middle example.com. You cannot man-in-the-middle anything else. What we did now is we manipulated the structure of the certificates to make our rogue certificate into an intermediate certificate authority. Remember the graph that Jake showed on one of the previous slides, where you had the tree of the certificates? You have the root certificate authority, which is the one that RapidSSL uses. And we have a signature from that to our rogue cert. And our rogue cert is an intermediate certificate authority, which has the ability to sign any other cert that's located under it in the tree. This gives us the full power of having a certificate authority, and we only need to do the attack once, because once we have the CA cert, we can use it indefinitely, or at least until it expires. So the way we did this is we fit the entire Rogue CA cert into the first 500 bytes of the certificate, which in the real cert were taken up by the name. We used a very long domain name for our cert to get the alignment right. And if you look at the T-shirts that my colleagues are wearing, you'll see the domain name. It's exactly 64 characters, which is the maximum number allowed. And I don't know if you can see it very well, but it says, I broke the internet and all I got was this T-shirt, .freedom.org. This is a legitimate domain that I own, and we obtained the legitimate certificate was for that domain. And then we could copy the signature from it into the fake or into the Rogue certificate. One other extra point. We still had to have the bottom parts of the legitimate certificate copied into the fake certificate, but we had to get the browsers to ignore them when they received the Rogue certificate. So we used a very long Netscape comment extension, which allows you to put basically arbitrary data into the certificate. It's ignored by the browser, so it doesn't cause any problems. So with this, we were able to generate a Rogue CA certificate. It only took us 4 attempts. This means 4 weekends. We did it every weekend over a month. The main problems we had were with timing. Sometimes we would not get the certificate issued at the exact second that we needed, but 1 second later. Sometimes somebody else would just come in right before our request and steal our serial number. It would actually be interesting to spider the web again to try to find the website that has that serial number in it. I don't know what we'll do to them. But the total cost of all the certificates we had to buy was actually only $657, which is not too bad. This was because RapidSSL allowed us to reissue each certificate up to 20 times. So we actually only paid $45, but that was for 20 certificates. The cost was not prohibitive at all. So what can we do having this certificate? Jake is going to tell you more about it.
So I already went into this a little bit, but this is an example if you haven't gone to the website or you don't have a laptop. This is what the chain looks like. There's a couple of interesting things here. One is that it's valid. That's probably obvious. But the other is that we named our certificate authority MD5 Collisions Incorporated. If you look through the certificate authority list and you actually see intermediate SSL certificates in the wild, they have crazy names that you can never imagine, or they have like some corporation's name but like some sub-business unit of it or something like this. And so it's totally reasonable in the wild to see a certificate chain like this. And so what you can do with that is essentially be one of those sub-business units. And it's just business as usual in the X509 commercial world. So we, of course, chose a name that would be funny. Other people could choose a name that was, yes, you're not laughing. Well, it's hard to impress these guys. So you could choose any name that you'd like. And of course, this is extremely difficult to understand which business units are actually real, which ones are not. And also, the cute thing about this is that when we say perfect man-in-the-middle attacks, we talked about mitigating this with some vendors. And essentially, you know, they said, well, you need to do these things. That's difficult, maybe. I'm not so sure about that. So who here use wireless networks? I mean, these things could be bad, but they said, well, we can check for certificates that end with MD5. And actually, the way that this works, we can sign with whatever hashing algorithm we like. So our Rogue CA man-in-the-middle tool, it just goes ahead and signs with the Secure SHA-1 to make sure that you know that you're secure. So there's some countermeasures here. The spoof.